The objective of this video is to describe how NTLAN, also known as NTLM, to describe how NTLAN Manager is vulnerable to exploitation. So as an introduction, let me just start by saying exactly what it is. NTLAN Manager is a suite of Microsoft security protocols that provides authentication, integrity, and confidentiality to users. And if you're watching this, you should know what a protocol is, and I want to make sure my students really understand the concept of a protocol. So be sure to answer that question. A protocol is just an agreed upon set of rules for communication. So these NTLM protocols, they are the successor to an authentication protocol in Microsoft LAN Manager, once upon a time known as LANman, and this is an older Microsoft product. And if you love acronyms, this lesson is for you. So here's the LANman giving the crown to the person who's up next. And even this slide I made is a little outdated because then I learned that Cerberus is the new NTLM. And even NTLM now is not a reliable way to authenticate people. Now, if you've ever been to Microsoft's Dev Center site, it's really terrific. I suggest you go there. And they are the first to admit that NTLM is old, and the Microsoft Cerberus security package adds greater security than the NTLM to systems on a network. Although Microsoft Cerberus is the protocol of choice, NTLM is still supported, and you'll see it out there. This dev site goes on to say things like, your application should not access the NTLM security package directly, and instead it should use the Negotiate security package. The Negotiate security package selects between Cerberus and NTLM. Negotiate selects Cerberus unless it cannot be used by one of the systems involved in the authentication. So if the client doesn't support it, or the servers that the client's trying to connect to doesn't support Cerberus, then it will go ahead and use NTLM, so very reluctantly. Now, the NTLM protocol suite is implemented in a security support provider, which combines the LAN Manager authentication protocol. Okay, the NTLM protocol suite is implemented in security support provider. This is an API. So the security protocol is implemented in an API that anybody can use in an attempt to create security. Inside of this API, it is combining the LAN Manager, the old thing, right, LANman. It combines that, NTLM version 1 and 2, and even NTLM2 session protocols, all in this single package. It's okay not to totally wrap your mind around that paragraph, because I really just want you to walk away with the knowledge of what an API is. We've covered these before in class, so maybe if I read this sentence, you'll remember what it means. It says Win32 API used by Microsoft Windows systems to perform a variety of security-related operations such as authentication. So this security support provider is a Win32 API. And as a second hint as to what an API is, just look right here. If I created an app, any app, and I wanted somebody to be able to log in using a thumbprint or maybe a PIN number, I don't necessarily have to code the ability to do that myself into my app. I can just go out there and find that API. So in Eli 5, when you use an API, you're using an interface. This is like a block of code that lets the program you write control or access another program somebody else wrote. So as an analogy, suppose your program is a robot, and you want that robot to get in a car and drive across the city. Do you program the robot to know how much gas is needed to be sprayed into the cylinder? Does the robot need to know the details of the voltage needed for the radio or spark plugs in the car? No, you would program that robot to know just how to start the car, how to steer, and how to brake. Oh, and of course, how to use the gas. These are four relatively simple things. All the other layers below that level of abstraction is for the car to worry about, not the robot itself. So in this sense, the robot's your program, and the API, the interface, is the pedals, the steering wheel, the brake, etc. And over here I said, I like to think of this word, interface, more like bridge. It's the bridge to get from one thing you want to another thing. The brake pedal interface. The brake is a bridge for you to take in order to stop the car. So basically, everything I just said here, and then this got me to thinking, what's the difference between APIs and just libraries for different programming languages? Well, apparently there is very little difference, except APIs are generally just much larger. And if you want to wrap your mind more around APIs, other tech companies offer these because they want to increase the amount of people who go or use their company. So you'll find APIs for like Google with Google Maps, you'll find them with YouTube, and these biggest companies here are often clumped together in what is known as FANG. So they're succeeding in the market of increasing the number of people who use their product. Now let's refocus from APIs to these security protocols in NTLM. Whether these protocols are used or can be used on a system is governed by what's called group policy in Microsoft. You go to your group policy settings, and there are different versions of Windows with different default settings. To see what your default settings are, you just go to your group policy settings, and that's where they'll be. Apparently, different versions of Windows will have different defaults. And to narrow down on the vulnerability here, NTLM does something called a challenge response authentication protocol. This uses 3 messages to authenticate a client. And there is a 4th integrity message, but this is optional. First, the client establishes a network path to the server and sends a negotiate message. You remember this in the beginning of our slideshow here, where I said hopefully negotiate actually chooses Cerberus instead of NTLM to use. So establishes a path and sends this negotiate message. A great resource to wrap your mind around this process is a Clemson website. It says a fundamental problem with passwords is that passwords are used repeatedly. When a password is intercepted, the authentication system cannot determine if the real user is entering the password or if an imposter is supplying the password. One strategy to counter the situation is to allow a password to be used only once. There are several different types of challenge response systems. So at the shallowest level, this sounds terrific. Like this challenge response protocol creates a system for you to use a one-time password and then never use that type of password again. It sounds great, but I think because of people adding complexity to this process of secure communication, the complexity can have these flaws. Pictures like this kind of muddle the idea that an attacker could be right in the middle here intercepting this, and that's where the vulnerability is. So you type in a password with a username that gets sent to a server. So there's this path that is established. Like I said here, there's a negotiate message that happens, and then that password is used to create another password. But you, the user, you do not have to worry about the complexity of this new password, this new one-time password. That's created because of this challenge message. Once this challenge is sent, the client takes that challenge and adds a special number to it, and out comes their response. And if the response is valid, according to the domain controller, then the person has gained access to that network. So right here, I wanted you to zero in on what the negotiate message code does, and then I want you to zoom out and think about our networking lessons as a whole. If the negotiate message establishes this connection path to a server and establishes what protocols are going to be used, whether it's NTLM or Cerberus, is there another protocol you know of, maybe TCP, that expects a reply and then gives another reply acknowledging that it has received the reply from the server in the first place? This type of synchronization acknowledge dance, that's what this NTLM process or authentication process reminds me of. A challenge response protocol is just like the TCP protocol, but with the word security slapped on it. To dig a little bit more into why it's secure, let's talk about the whole authenticate message. The client responds to the challenge with this authenticate message. That's the official term for it, I suppose. And now this protocol uses one or both of the hashed password values. Both of these values are served on the server. I mentioned that earlier, the domain controller. This result is saved there. And because NTLM suffers from a lack of salting, if you grab the hash from the server somehow, then you can easily figure out the password. And I suppose the point isn't you need to know the password. The point is you authenticate without typing in the password because you figured out the hash. Are you wondering if not salting a password is a bad idea? The answer is yes. And to simplify salt, well, let me first make sure you understand what a hash is. Say your password is the word hello. We don't want to just store this somewhere. So that password, the ASCII value for each of these letters, is put through some sort of function, a one-way function, by the way, and out comes this jumbled garbledness. So because this was jumbled inside of some sort of function, the result right here is definitely complex and large. But using just this one-way function, you can throw in a ton of words, like a lot of dictionary words, and when you get the right output, well, then you're good. You're authenticated. So some people, security experts, like to do something called adding salt. So they'll take hello, they'll add 3AB9 to it, and then they'll throw it through the hash function, and that's supposed to make this more complex. Because you can't just keep testing these dictionary words in the function, you would have to test some extra randomness. So you should definitely, if you're taking notes, write down what a hash is and what salting means. And I feel like it's okay if we're oversimplifying this now because the people watching these types of videos should be beginners. Any of you experts out there watching, feel free to correct me if I'm getting any of this wrong. So the basic ideas of hashing is you use a function to, it says map keys, as in passwords, keys and passwords, same thing. So to map these into positions in what's called a hash table. So going back to what we were talking about before, the word fox put in a function can have this pattern come out. And I call it a pattern because every time you put a capital F-O-X, every time that exact result will come out. And it's very hard to predict what is coming out because if we go down here, if I put in this whole sentence, the red fox runs across the ice, I put that into the same function and out comes the same number of letters and numbers, even though the input was much larger. So there's something going on here that's pretty complicated. And the hash sum, which is right here, is useful for security. And if you like your algebra, it says here, if data item or element E has key of K and H is a hash function, then E is stored in position H parenthesis K. To search for E, compute HK to locate position. I've never been one for these types of explanations. I'm more of a visual learner. And I think this visual right here does an even better job of explaining what a hash function does. And go back to the word map right there. So if I put in John Smith, that maps to the value of 2 right here. Same with Lisa Smith over here. It maps to the number 1. And see, it's the same number of digits, which is definitely typical of hashes. But you might notice a problem. That's why it says that was bad, and you should feel bad. Because people who create these hash functions, they do not want the concept called collisions to occur. So if I put John Smith in, and then I put Sandra D, and somehow the output is 2 for both of them, that is very bad. And it took a while, but we just found that in SHA 1, these guys who are hammering at that function for years and years now, I guess, they have finally found collision to have occurred. So we're calling SHA-1 a bad hashing algorithm now. Now NTLM gets a little more complex. The 2 parts of the password hash, there's an LM hash, which this is a DES-based function applied to the first 14 characters of the password, and it's converted to the traditional 8-bit character set. And so then if the password's more than 14 characters, this thing called the NT hash occurs, and this is an MD4 of the little Indian UTF-16 Unicode password. Oh my gosh, all terms with their own separate videos. But basically there are 2 hash values. So because I love pseudocode, let me take you to this Microsoft site right here where you could see the challenge message.server challenge has the following pseudocode. And it says here an 8-bit challenge message generated by the server. And I've already given up on the idea of reading this to you, but it wouldn't hurt if I slowly scroll and you pause if you'd like to really digest what this pseudocode is saying. And by the way, this is for NTLM version 1. I clicked on version 2, and now we can look at that. How fun would that be to create a Venn diagram on these two pseudocodes? What are the similarities and differences between them? But that's all much beyond the scope of this class. I wanted this lesson to be more about APIs and the concept of hashing integers. Nope, I meant to say in the context of a protocol, so hashing in the context of a protocol. And I think this real shallow level of knowledge about NTLM would be helpful, especially for my students who like playing CTFs, because I've heard of a few challenges that uses this concept. So to wrap up, NTLM remains vulnerable to an attack called Pass the Hash, and this is a variant on the reflection attack, which was also addressed by Microsoft Security Update MS08068. And something to consider, Metasploit can be used in many cases to obtain credentials from one machine, which can be used to gain control of another machine. There's a toolkit called Squirtle, which can be used to leverage website cross-site scripting attacks into attacks on nearby assets via NTLM. And I'd love to be able to use a tool like Metasploit in class. There is an active community, and I learn a lot from reading the discussions in communities, but a picture like this might say quite a bit. Just look through all the options and the type of information you can read from a tool like Metasploit. So NTLM, in February 2010, Amplia Security discovered several flaws in this authentication mechanism. It broke the security of the protocol, allowing attackers to gain read-write access to files and remote code execution. So pretty much all the bad things that can happen, and Amplia Security had discovered this all the way back in 2010. Time of this video, we're in 2019, and today, January 8th, 2019, a student of mine did a flash talk or flash threat Friday on Microsoft Exchange servers being vulnerable because of this. So I want to end this lesson now, and I'm going to make a follow-up, so make sure to watch that if you want to learn more about this. But that's enough learning for today. In the follow-up, we're going to spend most of the time just looking at discussions from other people on other sites, and I'll dig into this particular vulnerability I foreshadowed for you here. If you're in class, though, I'd like you to go ahead and tell me what makes NTLAN Manager vulnerable.